Okay, the next that we are going to discuss, that is on solids of revolution. We are going to find the volume using circular disc. So here, supposing we have here is two curves, okay, two curves, and then we are going to revolve this one. As you can see here, that is the direction of its revolution. That will be revolved about the y-axis. So if that is being revolved about the y-axis, and then we are going to get a small horizontal strip. So this is now the small horizontal strip. If that is horizontal, that is a very small portion of your y, that is your dy. So if that is revolved about the y-axis, we can form a disc. So example, we have this one. Okay, this is now the replica of the figure here. So we have this one. If we are going to revolve this one about the y-axis, so therefore we revolve this one. So this one revolve about the y-axis, and then so do with this one, revolve about the y-axis. Okay, so we can form a circular disc out of this horizontal strip. To find the volume of that circular disc, we will have the formula. Volume is equal to pi, the integral of x sub r, x right squared minus x left squared dy, evaluated from y sub 1 to y sub 2. Okay, x right, that is at the rightmost portion equation, x left, that is the equation at the leftmost portion. Okay, the next example, that is here we want to find the volume of the solid form by revolving about the x-axis. So here we have two curves, and then we are going to get a small strip here because your strip is vertical, that is dx, and we are going to revolve that about the x-axis. If we are going to revolve that about the x-axis, we can form a circular disc. So this one, okay, this one revolve about the x-axis. This one revolve about the x-axis. Then we can form a circular disc. Then to find the volume of the solid that is being formed by revolving about the x-axis, the formula, that is equal to volume is equal to pi, the integral of y up minus y down, that is y up squared minus y down squared, or y lower and upper, y upper minus y lower, dx. So if what is your strip, so that is your, in terms of your variable, dx, evaluated from x1 to x sub 2. So y up, y down. Okay, we can also find the volume using hollow cylindrical shell. Okay, if we are going to, okay, example, we have formed an area between two curves, then we are going to take a vertical strip. If we are going to revolve this about the x-axis, we can form a disc. But then if we are going to revolve this one about the y-axis here, we can form a cylindrical shell. So we have here, this is now the replica of this one. We form an area between two curves, then we take a vertical strip, then we revolve that one about the y-axis. So this is your strip, revolve about the y-axis. Then this one, revolve about the y-axis. So we can form a cylindrical shell. To find the volume for that, we have volume is equal to the integral of 2 pi x sub z, y up minus y down, dx, evaluated from x sub 1 to x sub 2. X sub z, as you can see here, x sub z, that is the radius of the cylindrical shell that is being formed. So x sub z, that is the radius of the cylindrical shell that is being formed. And then y up, equation of the curve at the upper part, y lower, that is, or y down, that is the equation of the curve at the lower part. So YL. Okay. Okay, next. So here, we are going to revolve. Okay. If you are going to look at the arrow, we will revolve the horizontal strip about the x-axis. If we are going to revolve here about the y-axis, that would become a disc. But if we are going to revolve this one about the x-axis, that would become a cylindrical shell. So therefore, we will copy that one. So an area that is being formed between two curves, then we will get a horizontal strip. So that is dy, because that is a strip horizontal. So therefore, if we are going to revolve about the x-axis, so therefore we are going to revolve that here. Okay, we revolve that here. So do it with this one, revolve. Okay, so we form a cylindrical shell. So y sub c here, as you can see, y sub c, that is the radius of the cylindrical shell. So to find the volume is equal to 2 pi y sub c xr minus xl. So equation x to the right minus x left dy, evaluated from y sub 1 to y sub 2. So x right, that is the equation of the curve at the rightmost portion. X left, that is the equation of the curve at the leftmost portion. Okay? Okay. The first example we have here. Given is the area in the first quadrant. Okay? Take note that the area that we are concerned, that is at the first quadrant. Okay, boundary, bounded by, so what are the boundary? boundaries. So, bounded by x squared is equal to 8y. So, that is the first boundary. Another boundary, the line y minus 2 and the y-axis. So, again, given is the area in the first quadrant bounded by x squared is equal to 8y. The line y is minus 2 is equal to 0 and the y-axis. Okay. So, the area that we are concerned of, that is located at the first quadrant. And what are the boundaries? So, the boundaries, that is the curve x squared is equal to 8y. Another boundary, the line y minus 2. Another boundary, the y-axis. Okay. The question here, what is the volume generated when this area is revolved about the line y minus 2 is equal to 0? So what are we going to do? We are going to revolve about the line y minus 2. Okay. So, solution here. So, we are going to plot the given curve. So, we have y, x. So, if we are going to look at this one, x squared is equal to 8y. That is a form of, what form? Parabola. Okay. If that is a parabola, if you are going to look at here, x squared. So, the one that is being curved is the x-axis because you have an exponent at your x. So, therefore, that is an indicator that your x curve for this given. So, what is now the type of parabola? Is it facing upward or facing downward? Okay. If x squared is equal to positive, that is facing upward. If you will have x squared equal to negative, that is facing downward. So in our given, this is a parabola that is facing upward. So that is facing up. And what is its... So, the vertex here, okay, vertex, that is 0, 0. So, you will have your 0, 0 here, okay, because that is x squared alone. So, therefore, we will have our vertex at 0, 0, and then... What is now the point of intersection? Okay. Point of intersection between, okay, between the parabola, okay, this is now the parabola facing upward, okay. So, when will your parabola intersect with line? Okay, line y is equal to 2. So, line y is equal to 2, that is simply a horizontal line that will cut at y is equal to 2. That is y is equal to 2. So, to find its point of intersection, you simply substitute the value of y to your x squared is equal to 8y. If we are going to substitute the value of y, so you will have to 8y, what will happen? You will have 8 times 2, you will have 16. So, x squared is equal to 16. X, therefore, is equal to plus minus 4. Because the square root of 16, that is equal to 4. So therefore, the point of intersection, that is equal to 4 and 2. That is the point of intersection. So if we are going to, okay, what we're going to do, can we use horizontal strip here? Okay. Why we use vertical strip? Okay. We cannot use horizontal strip here because if we will use horizontal strip, you cannot have x right minus x left. Why? Because when you are going to draw a small strip here, that cannot touch the two equation. What we need is that can touch the two equation. So if we will have vertical strip, that can touch the equation y is equal to 2, and that can touch the other equation x squared is equal to 8y. Okay? So therefore, our strip here is vertical. Then we are going to revolve that vertical strip, okay, about y is equal to 2. Okay. So, we will not revolve about x-axis, but we are going to revolve at y is equal to 2. So, therefore, meaning, what does it mean? We are going to revolve this here. We are going to revolve at y is equal to 2. Then we can form a disc, right? So, therefore, if we are going to draw the volume that is being formed, if we are going to revolve that about y is equal to 2, you can see it that here, okay? This is now the volume that can be formed if we are going to revolve about y is equal to 2, okay? So, look at the boundaries, okay? Boundaries. What is being considered here? That is only at the first quadrant, okay? This is the first quadrant, okay? So, boundary here, that is your curve x squared is equal to 8y. This is a first boundary. Second boundary line, that is y is equal to positive 2. Another boundary, that is y axis. Okay. So, this is now the area of concern. So, if we are going to revolve this one about y is equal to 2, so therefore, you will have from your x-axis towards y is equal to 2. So, the unit here, the total distance, that is equivalent to 2. Any distance, okay, any distance from the x-axis up, that is equivalent to what distance? Y. Here, this one, that is still y. Okay. So, that's the reason the radius of this that is being formed, that is equivalent to 2 at any vertical strip here that is being formed, that is equal to 2 minus y. So, therefore, formula, okay, what formula we are going to use? Okay, solution. So, solution here, we have, okay, volume, that is equal to pi y up minus y down squared dx. Okay. For this case, that we are going to revolve about the line, our formula, you will have volume is equal to pi r squared dx. So dv is equal to pi r squared dx. So wherein the variable for this one, because this is vertical strip, that is dx. So we are going to express inside in terms of x. So in terms of x, given x squared is equal to 8y. So therefore, x squared is equal to 8y. Y is equal to x squared over 8. Then substitute that one. So dv is equal to pi 2 minus x squared over 8 squared dx. So dv therefore, LCD, so 16 minus x squared over 8 squared dx. So integrate both sides. So therefore, you will have v is equal to pi over 64. Why 64? Because that is 8 square. So 64. 16 minus x squared, that is, you will have 256 minus 32x squared plus x to the 4th dx. And then we are going to evaluate this one. Limit 0 to 4. Our answer will be equal to 26.81 cubic units. So here is the solution. How we arrive at 26.81 cubic units. So we have here 256x minus 32 over 3x cubed plus x to the 5th over 5 evaluated from 0 to 4. So therefore you will have 256. So evaluated from 0 to 4, lower limit, upper limit, so 4 minus 0. Then you will have x cubed, so 4 cubed minus 0 cubed, plus x to the 5th, you will have 4 to the 5th minus 0 to the 5th over 5. So by using your calculator, you will arrive at 26.81 cubic units. So I have here shown how to find for the point of intersection, which I have discussed a while ago. And then here is the figure for our dist. So we have here the radius, the thickness, that is dx. So radius, that is 2 minus y. So if you are going to look at here, this is now your dx that is being revolved about the line. Y is equal to 2. So volume, that is pi r squared times height. So volume pi, 2 minus y is your radius squared. And the height, the thickness of your disc, that is dx. So that's the reason we arrive at that one. Okay?